Hi everyone, good morning, good afternoon to all. Okay, so in my today's session, I'm going to cover the principles associated with the microservices architecture, the way how we use solid principles for object oriented programming, okay, or RESTful architecture. In the same way, for microservices, we make use of IDEALS. Okay, so let's start with it because as most of the businesses have started adopting microservices architecture for their business applications, so nowadays understanding microservices architectures and its related principles has become vital. Okay, so let's start with this. So microservice architectures are the default choice for building and modernizing enterprise solutions for our modern businesses. Okay, adoption of this paradigm has happened relatively recently. However, the question is now is how to do it properly and to a much lesser extent if anyone should do it in the first place. Okay, it directly affects the flexibility, reliability, scalability, and performance of our digital products. Okay, guys. Till now we were making use of RESTful architecture basically. Okay, or I can say the MVC architectures using which we used to create our web applications. So it's basically a monolithic structure in case of RESTful architecture or MVC architecture, where all your services were kept inside your business layer basically, and we used to deploy those business layer services on our servers. Okay, so any small change to even a simple or a small service or even little change, the deployment was done to the entire application or at the entire services level. Okay, so that was the case with this layered architecture, or I can say this RESTful architecture. But now with the introduction of microservices, things are getting changed. Okay, and that's why they are saying while deciding which architecture to choose should be very careful, because it is going to directly affect the flexibility, reliability, scalability, and performance of our digital products. Okay, we must understand our products properly and then decide which architecture suits well. Okay, and for most of the modern these business applications or business products, I have seen that many people are migrating to microservices architecture because it is being a best fit, especially when it comes to performance and when it comes to ease of deployment. Okay, so that is the reason people are migrating to microservices architecture. Experience with the microservices collected over time results in best practices, patterns to follow, and anti-patterns to avoid. So again, we have recently started implementing microservices. Okay, so we should get good experience with this architecture. Okay, and over the period of time we can make use of this experience in order to choose best practices and allow the anti-patterns. Okay, ideals is considered an equivalent of the solid principles from object-oriented design in the world of microservices. Okay, as you will see, not all the solid principles have a direct translation into microservices architecture and vice versa. Okay, so you can't apply the solid principles straight away to your microservices architecture, but few of them we can utilize basically. Okay, that's what they are saying. But there are new principles. Okay, there are a few which we can make use of, and but there are new principles which have no equivalent in solid. Okay, which is completely different here. So what are these ideals? Now start with one by one letters. This I is meant for interface segregation. Interface segregation was there in solid principle also, and yes, it is going to add a value in microservices architecture. Okay, so APIs too often the APIs too often attempt to satisfy the needs of all the clients, okay, or API consumers you can say, and as a result they become a bloated set of services that are supposed to serve everyone, but in reality they are not efficient for any of the consumers. Okay, so this is like it becomes the service contract itself becomes a big fat interface kind of. Okay, so even if for example a mobile device don't want to use some of the services, provided by your service, but still it is forced to make use of that if we don't follow the interface segregation. Okay, so that's what they are saying. APIs too often attempt to satisfy the needs of all clients, and as a result they become a bloated set of services that are supposed to serve anyone, but in reality are not efficient for any of the consumers. Different interfaces should be available for different consumers. They may require different messages and contracts, different communication protocols. Okay, for example, internal services may prefer gRPC over HTTP, or even we can make use of TCP in some scenarios, okay, where file related operations are involved, or a different aggregation of messages. So what is the approach, basically how we can implement interface segregation in the microservices architecture? So they have come up with the concept of BFF, not best friend forever, guys. So it's a back end for the front end, basically. Okay, so what we are going to do, see, we have this category of clients. Web browser apps are there, mobile apps are there, desktop applications are there, and there are some other Windows services are there. So in each of these different kind of client applications, okay, we have to extract a backend for front end, basically an interface only, okay, which satisfy only the needs of web browser app or client specific needs, I can say only the mobile apps requirements. So we have to come up with the interface or contracts which can be only used by those category of clients or devices. Okay, and then this backend for front end basically acts as a proxy, I can say. It receives the request from your client application or device, and then it forwards it to your actual microservice. Okay, and also it does a lot of transformations. Okay, when it receives the message is entirely different which is sent from a browser application. The message is entirely different when it is sent from a mobile application, okay, and for desktop and background services. But it is the responsibility of this BFF which properly translates that message so that the actual microservice can understand and process it and return the response. Again, it is the responsibility of BFF to transform the response in such a way that it can be consumable by your end devices, like it may be a web browser based application, it may be a mobile application or some service. Okay, so that is the role of BFFs. So this way basically you are segregating, okay, the interface. So basically if I go with the microservice, this is the big fat interface in my scenario. Okay, it has all the functionalities, but it is the responsibility of this BFF, or it is our responsibility to segregate basically all those interfaces or the functionalities which are only required for a specific category of devices into their own BFFs. So that is interface segregation. So I hope you people understood how it works over here. Deployability. The concerns of application designers and developers has been the proper decomposition of software components into smaller parts which adequate responsibilities and functions. Okay, so in most of the scenarios it is the concern of the application designers and developers, okay, in order to decompose the software components in such a way that they have the smaller or adequate responsibilities or single responsibility, I can think. Okay, they have very small responsibilities. Now, because of the distributed nature of microservices, deployment is a critical part which also affects the design of the components. Okay, continuous deployment means that often services are deployed in different versions and you have to be fully aware of it. Okay, the moment you decompose your application services which were basically earlier with RESTful architecture, which were in monolithic in nature, where you used to do only one deployment for each release. Okay, for each release, for example, once in a 3 month you do a release, and on that release you used to deploy everything at one shot. But now with the microservices architecture, each and every small and independent service which was there in RESTful services become a microservice now. Okay, now you should be very careful because you have to do continuous deployments. Okay, there may be enhancements may come for a small microservice, or okay, there may be a bug fixes coming for a microservice. So you are not required to deploy everything at one shot. Now you are deploying wherever the need is. Basically, if a microservice was requiring enhancement, you did enhancement and deploy it independently. None of the other microservices are disturbed, they will work as it is. And what is the result of this? All the microservices build numbers or the versions are different basically in this architecture, because you are doing deployments as per the need spaces basically. Okay, so continuous deployment means that often services are deployed in different versions and you have to be fully aware of it. And of course, one of the key principles is that they have to be always to be ready to deploy. Okay, so the key principle is that the microservices which you are going to change or you fix, it should be in such a way that it should be always in a ready to deploy state. Okay, so deployability as a requirement cannot be addressed later anymore. Okay, with the microservices architecture, always remember this statement. Deployability as a requirement cannot be addressed later anymore. You should decide, you should take proper decisions during the design itself with respect to CI/CD also, guys. Okay. Containers and container orchestrators such as Kubernetes have become the de facto industry standard for deployment. Yes, so Kubernetes is the framework or the tool which is the de facto standard which most of the people are making use for deploying the microservices. Okay, there are advanced tools for monitoring, tracing and traffic management, and the service meshes are growing in popularity. Okay, so you can explore more on this on internet, guys, with respect to Kubernetes. Okay, serverless architectures make it even easier to deploy fine-grained functions as services. Okay, what is the serverless architecture? A serverless architecture is nothing but your queuing pattern or messaging architecture. So you people would be aware of message queues, right? Okay, so that basically constitutes a serverless architecture. One application, okay, one application processes some data and it puts a message basically into your message queue or a topic in order for further processing. Okay, that is done, it has fired the message and it forget about it. Now it is the responsibility of next service or microservice which is going to read that message from topic or queue, process it further, and again if required it can put one more message for further processing. So this is called basically message chaining. Okay, so or it can basically complete the processing and put one more message which constitutes the success basically, or it can write a successful record, a successful processed records into a database table also. Okay, so this is basically serverless architecture. Okay, where you are not required to maintain a web server basically, or in Azure terminology app service basically. So cloud service providers are competing to deliver the easiest and most comfortable solutions for DevOps teams. Agree? If you go with the Microsoft Azure Cloud, in order to support serverless architecture, they have introduced the concept of service bus. Okay, so using service bus, you can achieve the messaging or I can say serverless architecture. Okay. Well, that said, so that is the idea of deployability, that is the second letter of IDEALS, that is D, deployability. Okay, so when it comes to, always remember this point, when it comes to microservices architecture now onwards, there is no one shot deployment. No, whenever need comes, whenever a bug fix is there, whenever a hot fix is there, we should be in a position to do the deployment only for that microservice, and rest of the microservices are completely undisturbed, they will continue to work as it is. Okay, so deployment is a continuous process in microservices architecture. So that's the deployability, and this particular deployability when it comes to microservices architecture gives us a flexibility, okay, to push new changes as well as the bug fixes, hot fixes whenever we need, or whenever there is a urgency basically, or when we get a priority production issues. That is pretty nice thing, and I really like this approach. Okay, instead of doing a complete monolithic deployment, yes, we have basically broke them into smaller parts and we are achieving in small parts the deployments basically. That's enough for that, and let's move on. IDEALS, IDE, now E, event driven. Okay, to maximize flexibility, services are publishing events and responding to events. Okay, Event producers are not aware of their consumers, and consumers can receive messages from different producers as long as the topic and schema is right. Okay, there comes, here I just gave you the hint of serverless architecture, and here see the next topic or the next letter of the ideas itself is saying the event driven principle. Okay, so this opens up an entire world of possibilities. For instance, when a new employee is hired, multiple services may react to it, and new services interested in this event may be added later, all without modifying anything in the service which produced the event. However, nothing comes without its price, and the same applies to an event driven approach. Optimistic scenarios of workflows look easy and are easy to implement, but when you start treating the flow seriously, you have to add failures, retries, aborts, and compensation logic. Even relatively simple event flows and orchestrations become very complex graphs of dependencies. Okay, so understand this. If you are going with the event driven architectures, what happens is basically whenever an event takes place, as they explained over here, when an employee is hired, what are the various activities we do? First of all, the moment employee is hired, the employee details are filled into HR database. Okay, once the HR database tables are filled, the next thing comes is finance databases. There we need to create his compensation CTC structure and fill those records into his CTC. Then the department where he is going to work. Can you see the chain of events basically occurring here? Okay, and what is the event? A simple event. Employee has hired. One, that message is put first, the HR department will do the processing. Once that is done, it will put one more message. Okay, that message is read by again one or more departments. So this is how it goes basically. Not exactly message chaining I can say, but parallelly also a lot of subscribers who are interested in the event can subscribe and do the processing. So that's why they are mentioning we should be very careful, and what we need to implement is basically the optimistic scenarios of workflows look easy and are easy to implement, but when you start treating the flows seriously, you have to add, first of all, you have to add failure detection, you have to enable retries. Due to some reason, if the service is not able to read your message or message is lost, okay, we have to perform these retries. Aborts, compensation logic, when something goes wrong we have to compensate that. Okay, all these things should be taken care, which adds some additional complexity when it comes to event driven architecture. But trust me, this is fast. Okay, here you are not required to wait over a HTTP connection basically, guys. Okay, simply fire your event and forget. The rest of the things will be done by the respective stakeholders who are interested in the event. Okay, plus user interaction is often linear, not event driven. Okay, as most of our user interaction goes in linear fashion. First we hire the employee, then he will be added to HR databases, finance databases, the actual department where he is going to work, and a number of things. Okay, so that's what they say. Plus user interaction is often linear, not event driven, so it also affects the consumers of the services, which have to be able to handle its asynchronous nature. Always remember, event driven architecture is asynchronous in nature. Okay, the moment event happens or a message comes to your queue or topic, any number of subscribers can read that message, process in their own way at any time. Okay, you can't predict anything, everything happens asynchronously. Okay, fortunately there are new options and emerging standards to address all those complexities. So there are remedies to address all this asynchronous nature of event driven architecture. So definitely we can go through them, and yeah, we can implement in our designs. So typically this is how it looks like in event driven architecture. Okay, a microservice was doing some processing. Okay, for example, the employee registration microservice I can say. So it did the required necessary registration from its site, and then it put a message into this queue. Okay, or topic, you can say employee topic. Okay, now this detail will be read by a lot of subscribers. Okay, this event or message is read by subscriber 1 2 3. A subscriber can process it. Okay, a subscriber can opt to process it or completely neglect it also. It's up to the subscribers how they process. Okay, So see here, the moment a message came, a subscriber one is interested into that message. Okay, it did some processing, then handed over to Azure function or a background job for further processing. It triggered basically a Azure function or background job for further processing. Subscriber two completely ignored it because it is not interested in the message. Whereas subscriber 3 did some processing and it triggered one more microservice. So completely asynchronous in nature. Okay, this is how event driven architecture works, guys. Ideals. Okay, so we completed IDE. Now, what is A? Availability over consistency. This is the most controversial principle. This principle promotes the availability of the services over data accuracy and consistency. Okay, there are many business scenarios that do not tolerate inconsistencies and may result in financial losses, a degraded user experience, lost customer trust, and even be a hazard to the environment and human life. Many examples refer to completely different business domains than yours, okay, that are less regulated and usually more tolerable. For example, the inconsistency of social media posts between two devices is fine, while having inaccurate medical lab test results is a serious problem. Okay. So you can take example of, for example, I have a look at security first system for COVID-19 test results in blockchain. Okay. So be careful and analyze the business impact of the architectural decisions. Don't jump on the eventual consistency bandwagon because it may seem fashionable to do so. When used properly, which means when users clearly prefer faster information over its accuracy, it will be very beneficial for the performance and scalability of the digital solution. Patterns such as command query responsibility segregation (CQRS) help to remove performance and scalability bottlenecks by separating read operations from operations which modify the state of the system. Okay, that's called command query responsibility segregation. Okay, CQRS can be taken even further with the event sourcing strategy, which enables it to analyze and replay business transaction by storing a series of events which modify the state. Okay, so that's related to availability over consistency. Okay, loose coupling. When we think about loose coupling in the microservice architecture arena, we often think about API gateways, which enable the dynamic management of API providers and consumers. Gateways are an abstraction layer between the API consumers and the actual API providers. Okay, so you may be aware of this Azure API gateway management, and there is one more. Okay. Okay, there are a lot of technologies basically, yeah, which you can prefer. Another approach is to build backend for front-end APIs to tailor the API to the consumers, such as web apps or another service and mobile apps, which I have already explained. Backend for front-end in the uh, first principle itself, that is interface segregation. Okay, and let us remind you, you can have both with our Cooper dot. Okay, let's ignore that point. Okay, so what cannot be also forgotten is the loose coupling between different UI elements. As UI monoliths are still too common, micro frontends are something worth considering. Okay. Another pattern to be followed is to have separated data storages for different microservices instead of a tight coupling on a single database, which creates invisible dependencies, defying many benefits of the microservices architecture. So be careful whenever you design a microservice, always try to keep that microservice in the different repository and then try to maintain a different database for that microservice. Do not make your microservice to interact with the common database. Okay, it's a bad practice, guys. Okay, it is a preferred approach and it is recommended also that each and every microservice should deal with its own database. See, it's the concept of domain driven design. You should identify the domain which can be basically extracted as an independent subdomain from your complete business domain. Okay, so that subdomain should be designed in a microservice in such a way that it should not depend on additional data. It should not depend on additional data which is span across other databases. Okay, so always design the microservice in such a way that it should deal with its own domain. That's why we call it domain driven design here. Okay, okay, for example, if a microservice is dealing with reports, always keep the reports database, okay, a separate reports database for your microservice, and this microservice should only deal with the tables available in your reports databases. Basically, if it wants to communicate with user related information or inventory related information, then they should communicate with other microservices. Okay, so this is how it looks like basically. So this is the microservice, this is a queue, okay, or a topic. So you can put a lot of messages over here. The microservice can do some processing and keep on putting messages, and subscribers will subscribe to the messages. Again, it depends on them, again they can process or not, it's up to them. Okay. So this is how it looks. So both, basically both your consumer and producer, okay, they are completely loosely coupled. There is no hard-coded dependency by your consumer on the producer. Producer simply does some processing and puts message, and your consumer will simply, whenever available, it will simply read those messages and does the processing. That's why we have achieved a complete loose coupling with this particular principle, loose coupling. Okay, the consumer just does the responsibility of producing messages, whereas, oh sorry, the producer just does the responsibility of producing messages and put those messages onto queue or topic, and the subscriber or the consumer will just read those messages and they will opt to take action or not, it's up to them. Okay. Okay, ideals, the last letter S, that is a single responsibility. So this is the same as our solid single responsibility principle, but there's a little difference that I'm going to explain now. Single responsibility means the given component is doing one thing and not the other. The same applies to microservices also. Okay, adding too many functions to the microservice, well, makes it a small monolith with multiple internal dependencies. Okay, even adding too many functions to your microservice will also make it a small monolith. Okay, which we used to see in RESTful architecture, where it was a big monolith basically containing everything. Okay, so always remember, as single responsibility says, a class should change for only one and one reason. In the same way, a microservice should change for only one and one reason. Okay, so on the other hand, making microservices too granular creates more latency due to the multiple calls required to perform even the simplest business functions. Very frequently nowadays I am seeing whenever I receive some of the business requirements for these design activities. Okay, I have seen some examples where my team has resulted in creating very granular services. Okay, even to achieve a smallest functionality, they had ended up creating very small microservices, but that is not the practice. My microservices architecture doesn't mean that even a simple to simple functionality you turn it into a microservice. No, okay, it is completely a important design decision that we have to take, guys. Okay, see what happens, even if you start creating smaller microservices, then your application will spend most of its time in doing network operations only. Okay, even to get a simple employees address detail, if you write a microservice like address service, then what is the use? Okay, your employee microservice will make a call to address microservice just to get the address. Again, same way, if you created multiple microservices for smaller operations, then most of your time will be spent in network operations, and you know how costlier network operations are. Okay, so always remember, it is like exactly being at a optimal point. Okay, like 50%, you should not go below 50, you should not go above 50. Okay, you should be at right point basically. Okay, and you have to break your microservices in such a way that you will end up in creating microservices which should not spend more time on most of the business operations. Okay, so that's an example I have taken. Inventory read operation here. See, without single responsibility principle, okay, what happens if you keep both inventory service with read and write operation? For example, inventory read and inventory write operation, okay, into only one service. What happens is, okay, so client 1 makes inventory read operation, client 2 does inventory execution operation, okay, or write operation I can say. Okay, due to some reason if inventory service went down, okay, you can't perform any of the operations. So what is the right approach? Create two separate services: inventory read service, inventory write service. Again, I'm telling you about the granularity. Okay, you should not break inventory read service into further microservices. For example, inventory, okay, inventory, for example, if I take, okay, so okay, inventory balance microservice, okay, and then inventory details microservice, okay, and then inventory store keep unit microservice. No, don't do that. If you do that, basically what, even your simple inventory read operation is ending up in doing a lot of network operations. Basically you are creating a lot of communications within your microservices, okay, just to achieve a simple inventory read operation. No, create a simple inventory read service. This read service will take care of everything. That's it. Okay, it may be store keep unit, it may be available inventory, it may be other details. Everything should be inside this service only. Okay, and then inventory execution, same applies for inventory execution or write service. All write related operations should be taken care within one service only. Okay, so you should maintain the balance. Basically it's all about maintaining the balance. It should not go below 50, it should not go above 50, but it should be at a right place. So the concept of median I can say. Hope you people understood the concept of ideals. Okay, so the way how solids helped us to design object oriented design, okay, or to create object oriented systems with restful architecture, in the same way ideals will help us to create microservices or design microservices architecture. And yes, I have gone through a lot of internet articles in order to create this document. Okay, and I have taken good parts from them. Okay, and I would like to thank for all those writers who have written very nice articles on microservices architectures with respect to this ideals principle. Okay, thank you for listening, and I hope you people will find this useful and you people will implement in your upcoming microservice architecture based products. Okay, thank you.